Hi guys, welcome back to the Astro Imaging channel. Tonight's session is on 3D printing and astrophotography by Josh Smith. But as always, before we jump into that, I'm going to show off our image of the week. Of course, last week was Bubba Daniels, his rosette. And Bubba, if you're out there, I'm going to be sending you a quick link to this live hangout if you wanted to jump in and explain your image towards the end of the session. But this week, welcome to come on for next week is Christopher Gomez. I'm going to share that image right now. I think you can see it. Yes, Christopher Gomez is Lagoon and Trifid Nebula. And beautiful image, Christopher. Great job on this with a Stellar View 70T. Nice little scope there. But Chris, you are welcome to come on next week. If you can figure it out, drop me a message on Google+. I'll get you into the email list to get into the Hangout. It's become a little more difficult to get people in, so we're emailing that list out. And for anyone else out there that thinks they really want to get into the Hangout, just Google+ me a message and, with your email, and we'll get you in. But trying to click back. Let's see here. Not working. There we go. But for now, I am going to hand it right back over to Josh, who is welcome to take it away. There you go. Josh.
Thanks, Adam. Can you just confirm that my screen is showing?
I can see your screen. Okay,
great. All right, guys. So tonight we are going to do a presentation on 3D printing and astrophotography. I'm going to spend a little time talking kind of about what 3D printing is, spend a little bit of time explaining maybe how you can actually get into designing your own models. We'll talk about 3D printing in general, answer any questions you have. Then we'll go through some examples of why it's good in astrophotography and some examples of what we've actually done with it. There's a lot more out there, and definitely if anybody's done anything interesting, please add a comment or a link and let us know what you've done. We'd be happy to share it on here as well. So first, I'm just going to get into actually talking about what 3D printing is. So in the sense of the printer that I use and generally use, it's a form of additive manufacturing that creates layers of materials that fuse to each other to make a three-dimensional model of what you've designed. So I'm just going to come over here and share you this video. And as you can see, basically there is a carriage that is running on two axes, and it is going in the X and the Y axis and actually depositing plastic material onto this bed. And as it goes around and lays down a layer, every time it lays down a layer, the bed actually moves down just a tiny bit, and it goes through and does the same thing again. And so it'll keep going through and doing that all the way up until you have a full model. There's a lot of different kinds of additive manufacturing, 3D printing, whatever you want to call it. There's FDM, which is fused deposit modeling, and then there's SLS, SLA, DLP, EBM. We don't want to spend forever talking about them, but suffice to say there's kind of a little bit of different technologies for doing different things. There's different advantages to the different kinds of technologies. The beauty of the FDM is really that the hobbyist market and the prosumer market have more options for FDM than pretty much any other type of printing right now. Some of the other ones are actually starting to get down to the hobbyist level. I think the cheapest ones maybe I know of are like the Form 2 Plus, which I think is about somewhere around $2,500. But for these 3D printers, you can get them anywhere from $250 on Kickstarter for one of the cool new ones to all the way up to something like, you know, $500,000 or $1 million if you're running a company that needs a really big machine. The hobbyist level ones generally run between probably $500 and $2,000 or $3,000 for the ones that are really accessible. And we could take a little bit of time later today and talk about which printers are better at the end of the session, answer any questions that people have, see if there's anybody else in the room that knows a lot about 3D printers. I have a decent bit of experience from building a handful of printers a few years back. I've used 3D printers for the last 8 or 9 years, and now I currently have another one in my office and / workshop. So we'll go on and talk a little bit about the different kinds of materials that you can actually use with 3D printing. And this comes up a lot because people are wondering, you know, what can I actually do with these things that I 3D print? Are they strong enough to do what I want? And so just talking about the basics in FDM printing, which is pretty much all plastics, there's ABS, PLA, nylon, and there's really so many more. There's like wood filaments, there's stuff that's meant to kind of look like acrylic, there's see-through filaments, there's actually glass-filled plastics to give your plastic a lot of extra strength. There's plastics like nylon and other ones that are meant to be more flexible, so that if you're using them you can actually make parts into, you can design it to print out one way and be more flexible on the bed. There actually are metal 3D printers and ceramic 3D printers now, and while they're not really quite on the hobbyist level because they're very expensive, they actually are really, really impressive. I've got to see a few of those working in person. You know, I know that we've used them a little bit at previous jobs for really intricate designs that would have just been impossible to sheen and would have taken forever to make. I know that even NASA uses 3D printed metal parts sometimes because you can just make things that you really can't make otherwise. Ceramics are interesting. It's going to be interesting to see what people do with ceramics as that evolves, and you can actually even 3D print circuit boards now, and so people are starting to use them to not just the circuit board itself, but actually to print in the traces on the circuit boards. So there's really, I mean, pretty much the technology is, I don't want to say limitless, but it's continuing to grow. What you can do with it is really continuing to grow, and the quality of the prints that are coming off the printers are really becoming pretty impressive, even on the hobbyist level printers. So, but before you actually 3D print, you need to design your stuff in 3D. And so I just brought up a few of the programs here that are used to do that kind of design work. And you can actually use a lot of other programs too, but these are the ones that I have the most experience with. And somehow Pro-E got hidden on this list, but SolidWorks is probably maybe the most well-known 3D modeling program. Probably most engineering companies or development companies have a few licenses for SolidWorks. CATIA is another one that's used. I think that's used a lot in the auto industry. And I've dabbled with that a little bit. It's a little more complex, but probably even more powerful. Pro-E, again, I mentioned. Those programs are all very, very expensive and probably not something that you would be getting or using unless you're using it with the company or with your business. So I wanted to focus a little more on these other three, which are ones that are generally free and easily accessible, which is Fusion 360, SketchUp, and OpenSCAD. OpenSCAD's an interesting one that I haven't used a lot, more probably because of my background in SolidWorks and CATIA, that I just haven't done a lot of modeling the way that it's done in OpenSCAD. So if anyone wants to comment that uses it, I'm sure there's many programmers out there that listen to us, but it's very, very powerful and really a cool way to actually model stuff. SketchUp came out some years ago and was probably the first actually real free offer for this kind of modeling, and it's pretty user-friendly. There's lots of tutorials out there, and it gets the job done, especially for not super complex models. recently I've been looking for something to use at home and ran across Fusion 360, maybe only a few months ago, I think, at this point, and they actually offer a free version. And I want to be careful here. I believe the free version is for anybody that is a hobbyist or anybody that is running a business where they make under $100,000. Now, those terms can probably change anytime, but that's what I've started using recently. And for a free program, it is very, very impressive. I wouldn't say that it's quite on the same level as SolidWorks or CATIA or Pro-E, but if you are somebody who has a SolidWorks background or Pro-E or something like that, and you are looking for something because you want to be able to do 3D modeling at home, even just for astrophotography pieces, and want to send them out to get printed, it's really powerful. It has many of the same features that SolidWorks does, especially for small assemblies or simple single body models. So just to describe a little bit about kind of the workflow to get to a part that you actually need to print, I'll just briefly go through this before going into the astronomy related stuff. But essentially what you do is you build up a model in 3D. Almost you can imagine it sort of like it's being printed. But so you sketch surfaces, you extrude these bodies out in certain shapes, and you really take it into many steps to get to what you want. So I'm going to actually exit this presentation just for a quick minute to show the progression of something I designed for astrophotography. So Adam, can you see my CAD screen now?
Yes, I can.
Okay. All right, so just to give a small example of kind of the steps that would go into designing this for astrophotography. This is a adapter that I made for the QHY PoleMaster, and I'm just going to kind of keep stepping through steps here. And you can see as I step through them how this stuff is actually designed. And I'm not going to show you every one of these sketches. Maybe I'll skip forward a little bit here. But you can see kind of the control you have over these models and the steps that are taken to get there. And so the beauty of this really is that you can just make it exactly like you want it, and you can go through multiple iterations to get it exactly like you want it, and I'll touch on that in just a little bit. But so really this is Autodesk Fusion 360, and it works great for designing parts like this, and you can actually use Google SketchUp to do the same thing. I believe OpenSCAD would probably be able to do something like this as well, but it's probably a skill that you'll really want to get into. If you're interested in getting into 3D printing, you definitely need to have a decent 3D modeling skill. Probably at some point would get bored of just printing the trinkets that are freely available online. And if you're really getting into it, you're probably going to want to make custom stuff for yourself anyways. So I'll hop back into the presentation. And eventually you can actually create many body parts, sort of like this flat box that I've created here. And this is an assembly of 10 different parts that go into making this whole flat box. And so it helps you, if you're putting multi-bodies together, actually making sure that everything fits together and that you're hitting all the tolerances you want. So, like I said, I just encourage that you get into trying these programs out. It's a little bit of skill to get into them, but so is astrophotography. So, I'd say if you are able to take pictures of the night sky, you can probably figure out how to do this modeling. So, Adam, are there any questions before I move on?
There aren't yet. I have one, but I'm going to wait and see if you cover it in your presentation.
Okay, so we're going to keep it pretty short tonight, like I said, and we're going to hop into now the astrophotography section now that there's probably a little more comfort on what 3D printing is and how you can actually do it. And so the first question is, why 3D print for astrophotography? You know, what can we do for it? And the answer, well, there's quite a few answers to it. One of the main things is that we run into issues, and you need to solve these issues with something that you make. And the problem is that even the best engineers are pretty much never going to make the solution right in the first place. And I mean, you can even see that in products that come out in the market. Even the very, very best companies that put products out on the market, they have problems when they come out. And the problem with high volume manufactured products is that you have sunk a lot of money into actually making that product through your tooling. Whether it's plastic parts or metal parts or whatever it is, you've sunk a lot of money into sort of going down that path. And so you might make 10,000 telescopes, or you might make 500 cameras right at once. And that's because you save money by making stuff in volume. However, as the astrophotographer, you know that there are issues that you need to solve, and you don't have the kind of money to sink, $20,000 into a mold tool. So you want to come up with a solution. You want to try it out, and I mean, like I said, not even the best engineers have the perfect solution in the first place. And so that's where 3D printing is great, is that you can print out something. Maybe take a 2-hour print to print something out, and in this case maybe it's a batten off mask for your telescope. You can print it out, you can go out there and you put it on your scope, and you're like, darn, I just made it just a tiny bit too small and it's not quite fitting on my tube. Well, no big deal. You can go back and you can print it, and 2 hours later you have one that's a millimeter wider and it's just a perfect fit over your dew shield. So that's probably a pretty simple example of a fast prototype iteration. But once you start getting to multi-body designs, something like I made a helical focuser for the S-Big off-axis guider, and the off-axis guider for the S-Big is very, very sturdy, and it's well built, but it doesn't have a way to focus the cameras in them. So what we made was just basically a 2-part focuser for it that allows you to drop your camera in there. And as we were testing it out, and I made this for my dad, we tested it out and it seemed like it actually worked pretty well and the way we wanted it to the first time. But when we were using it, we were like, oh, well, what if we did this, which was we wanted to come up with a way to keep the camera actually, the guide camera, in the same orientation as you were focusing it. So we were like, well, let's try something out. So spent a couple hours modeling the design changes and printed it out, and the next day we could try it. And so really it cuts down on the solution cycle big time, because you can print stuff one day, try it out that night, and then print the improvements the next day. And I think that we might have gone through 13 iterations of that really just to perfect it. And it was worth it, because in the end we had a product that did exactly what we wanted it to do, and it was just basically the perfect custom solution. Which brings me into the next part, is that in astrophotography, unlike maybe some other things in this world, you build your setup. You have a conglomeration of a lot of different products from a lot of different companies with all kinds of different requirements for them. And when you're actually going to put that all together, sometimes stuff doesn't go together quite right. Sometimes the stuff that you want to buy, the accessories that you want to buy from your favorite vendor out there, they're not always made specifically for your gear. And the reason is, like I said, it's expensive to make a lot of this stuff. And if you buy something like a batten-off mask, a lot of times it'll be made for a 4 to a 6-inch scope, or it'll be made for an 8 to a 10-inch scope, and it doesn't take into consideration your focal length or your focal ratio on that 8-inch scope. It doesn't take into consideration necessarily your tube diameter or the outside diameter of your dew shield. So you end up with things that just aren't ideal. So if you ever used one of those batten-off masks, they're pretty nice, and they work reasonably well, or they might even work great. But a lot of times you have little workarounds that you have to use. You have to use little thumb screws that try to keep it from actually falling off of your telescope. And instead, if you are making one specifically for your telescope, which manufacturers typically probably can't afford to do, if you make it specifically for your telescope, it's going to work in any orientation. It's going to be custom made very much for your focal length and your focal ratio, and it's just going to work out perfect. And that kind of leads me into the cleaner and more elegant designs. When you're designing stuff specifically for your gear, and you make it just for your gear, then you can get away with less parts. A lot of times, if you're making universal adapters, or you're making universal components that or accessories that people are going to use, then it's it's not going to necessarily be perfect for your stuff. So you can have less parts when it's just for yours, because you don't need extra screws to help attach it. You don't need extra little clamps and stuff like that to attach it just to the perfect place. Now, it's also inexpensive, but I mean, there's some caveats to that, because one is, if you buy your own 3D printer, it's all relative. Like I said, the hobbyist 3D printers are probably $500 to a couple $1,000s. Which is certainly less than most telescopes or cameras that people use. If you want to send your part out to get printed, there's all kinds of different services to do that, and they can be very expensive, from the more professional ones to very inexpensive if you go to a place like 3dhubs.com and you just have somebody in your neighborhood happens to have one of these at home, and they'll print it for you. It's really a great service that you can look up. So it's inexpensive on a small scale. So if you want to make something, it is far less expensive for you to make one of them on your own than it is for you to make yourself a mold and get something shot. So it's a lot less risky as well. And the other great thing is that your design can always be improved. You might use something for 2 or 3 months and decide, well, this is working really well, but I want to make a couple small tweaks to it to make it work better. Or maybe you made something for a friend or a customer or something, and they came back to you and said, hey, this is great, I'm really liking how all this is working, but I'm having this one little issue with it, and I'd like you to see if you can do something about it. Well, sure, yeah, it's easy enough to sit down for a couple hours in CAD and knock those changes out and make the changes for them. So there's even more reasons to use it, but those are some of the the first most obvious ones that pop up off the bat. And so I don't really have a lot more to go through except for the examples, and I think going through and looking at these examples will really help kind of put a little bit more behind these explanations that I gave of why it's great for astrophotography. So Adam, I'll pause for one more minute and see if you have any questions before going through all these examples.
Few questions popped up. First, let me remind everyone out there, Q&A, you can type in your questions and I'll read them right out to Josh and we can answer them. But first question from Greg, which design software would you recommend for someone with very little mechanical design experience?
So, as with most things, it depends. It depends how intricate you want to get into your designs. If you really just want to make some boxes with lids on them, or you just want to make pretty simple shapes, then I think that Google SketchUp is probably the best and easiest one to use for that. There's enough tutorials out there, and the beginning tutorials will probably get you to the point where you can do that. So, I mean, if you really aren't going into much fine detail or have to do a lot of crazy stuff, I certainly would recommend Google SketchUp. As a free program, and again, I only have a few months experience with it, I am blown away by what Autodesk Fusion offers in a free product. I'm able to, at this point, design practically, or I've redesigned everything that I've designed before in astrophotography just to get myself kind of up to speed on this program. And in all honesty, and probably the 25 or 30 different things that I've designed, it's taught me, and it's also shown me that this program is pretty close to being as powerful for simpler stuff that as SolidWorks is. So if you want to get into something that with just a little more control, a little more dimensional accuracy, and a little more of an engineering mindset, then Fusion 360 is the one I would recommend.
Great. I can actually, while I haven't 3D printed, I used Google SketchUp to design my observatory so that I could put a fake person in there and see exactly how tall it had to be and all of that stuff. And the position of the telescope and how high the mount had to be was actually pretty convenient. Walter is asking, what about the durability of the printed project and flex associated with plastic parts? Isn't that an issue, especially with astrophotography?
Yes, so that's a very good question. So I've had this discussion with a lot of people, and the you know, it's tempting with a 3D printer just to make everything with it. So people will be like, well, great, we can just start making those threaded adapters, or we can make dovetails with them. And so the answer is it depends on what you're using it for, just like everything else. You know, you have to avoid the temptation to use it for everything, because certainly everything in astrophotography wants to be really rigid. If it's not rigid, you know, there's just a slew of problems that can come up. So probably the best example off the bat is threaded adapters. And I know that came up in the Cloudy Nights thread. Well, the day we can make threaded adapters out of metal is the day everything becomes easy. Well, you can do that now. You can do it pretty much to the precision that they can be machined, and they'll work great. And the issue is, if you make them out of metal and you 3D print them, they're going to cost, you know, probably $500. And so it's definitely not cost effective to go that route at this point for 3D printed metal stuff. If you want to try and 3D print threaded stuff in plastic, you know, you're not going to probably at this point be successful in adapting to an M42 adapter or a T-thread at this point. The resolution is there that you can get it there. I've printed out T-rings that I was able to thread on. The problem is that these things are made to, you know, hold up quite a bit of weight, and the plastics, if you just look at their data sheets, they aren't quite where aluminum is, for example, and it's not great. Threads aren't necessarily great, and some of that has to do with the orientation of the print. So again, I'll say it kind of depends. There are definitely examples. Like I said, I made that helical focuser for my dad, and my solution to that was, well, I needed something to be threaded, but I didn't have to thread to another metal piece. I just needed two plastic pieces to thread together. So I made a much coarser thread, and I was able to get it to be very, very smooth and also very, very durable. And that was just by making the thread a little coarser and the you know, the actual thread that comes out of it just a little bit bigger and more solid. So that was really successful. That is incredibly durable. As far as dovetails go, I have printed dovetails, and I've used them before. I wouldn't trust a big scope on it. I've used, I think, a small 70 or 80 millimeter scope when I did it, and it seemed like it worked fine. I certainly would recommend or think it's a great idea to print a dovetail up on top that can, you know, hold your electronics and your power distribution stuff, and so that way it's just kind of being reinforced by those rings and holding that stuff. As far as other things, as longevity or durability, you can look into the materials some and really start playing with what materials you're using to get that longevity out of it. There's materials that are UV resistant. There's materials like glass-filled nylon that are extremely strong, that, you know, are going to hold up to almost everything. So again, I wouldn't use it in a situation where you're putting a lot of weight on something and flexure could be an issue. I think at this point, it probably just doesn't make sense to do that. There's some things that you could print that would be okay, but as we go through these examples, I can show you some of the parts that I've used for a good deal of time successfully, that have held up, and I can talk about a few things that I've used that I wasn't in love with. So one other thing that I printed and made at one point was a 1 1/4 inch eyepiece extension, because I had been using a telescope to do little planetary stuff with a Barlow, and needed to bring the webcam out further, and I had to bring it out like 4 or 5 inches further, and just making a plastic tube that was 4 or 5 inches long, it ended up having to be so thick to be strong enough that it didn't flex, that it ended up being costly, more costly than buying an aluminum tube. So, like I said, I like to think about it in the way that I 3D print things that make sense and are cost effective to 3D print instead of doing something else with. I try to avoid the temptation just to print because you have one. You got to use it where it makes sense.
Bob Tracy is asking how the learning curve is moving from SolidWorks to Fusion 360.
I haven't finished doing that yet, so I can't tell you. As far as sketches and regular modeling, it's not too challenging. The hardest part is breaking habits, just things like, creating relations. You have to select entities in certain orders, and I have to remind myself over and over again to do it the way that Fusion 360 wants it instead of SolidWorks. But a lot of the rest of it is pretty similar. You still have a history tree. The way that it breaks up bodies and sketches and stuff is somewhat similar. So I would say the learning curve is it gets more challenging the more in depth you go with modeling. If you're just modeling simple stuff, it's not too bad. I don't know. Like I said, I've been at it a couple months, and it probably I would still get through designing something in SolidWorks probably in 50 to 60% of the time of Fusion 360, but that's just because every time I design something new, I run into something new that I haven't done yet in Fusion 360. But I was very skeptical that it could work and be powerful enough before trying it, and have been more and more pleased the more I've used it.
These questions are popping up quickly. Do you know of a service that will take your project file and use it to replicate something in metal after you've prototyped it in plastic? And that's going to kind of touch on my question, which is, you don't have to have a 3D, I think you touched on it, you don't have to have a 3D printer. You can send it out just like you would send out something to a printer, right? And did you say 3D Hub is the service, and maybe with metal printers you could do the same?
Yeah, 3D hubs. There's a lot of them out there, really, and again, it depends on the quality you want. 3D hubs is cool because you can search different printers in that area. You can search who has printers and what capabilities they have. If the idea is that you want to print something until it works right, but then you want it to be made out of metal, there's lots of options out there for that. Hundreds, and I think it would be unfair to point out anyone too specifically as an option, but there's quite a few of them out there that you can select. And certainly, if anyone wants to message me off of the presentation, I'd be happy to point them to a couple selections. There's like anything else, I would use different sources for different things. If I wanted somebody to use I don't know. If I wanted somebody to use a router to make me something, I would contact one place. If I wanted somebody to use a lathe to machine some metal parts, then I would contact somebody else. So it's very dependent on the project, but it's definitely an option, and I've done that as well. I've made things in plastic until I was happy with them, then ordered them in metal.
Alex is asking if there's an equivalent of a scanner if you want to copy a part.
Yes, there is, and again, the technology is wildly all over the place. Very interesting things. A couple projects I've done, you can take Xbox 360. The word's escaping me now. What's the little camera they have that can sense your motion? Oh, the Kinect. I've taken Kinects and actually scanned different things, and there's, if you YouTube Kinect and Scanner, then you can actually use this program to scan things and get fairly good representations of them. You can connect a handful of Kinects and put them around to get higher resolution scans of things. So you can spend, and you can even use your iPhone and take pictures you can take pictures of something from different orientations and upload it to this app, and the app will give you a 3D model of it that you can download as a different kind of file. And so, I mean, you can go, depending on how accurate and how nice you want the scan to be, you can go anywhere from, you know, a $2 app up to, you know, $200,000 scanners. They make little handheld laser scanners that you put a product on a turntable and scan it. There's 3D printers that have all-in-one solutions where they have a scanner built into the printer, and it'll scan something for you, and then it will print it for you. And again, you can spend a little bit or a lot of money, and the technology can spit out mediocre results to excellent results. Another thing that I was very impressed with was how well the Kinect worked. Especially once I hooked 2 or 3 up, I got very nice results. But you get into details like having to powder the outside surface of whatever you're scanning to make sure that it's reflecting the light properly, stuff like that. So it's very interesting stuff, and the very good machines are very, very capable, like sub-millimeter accuracy capable.
And Tolga's asking, can you use the student version of SW, which I believe is SolidWorks?
Yes, that's SolidWorks. And was there more to it, or was that it?
Sorry, I muted myself. That was it.
As far as I understand, and I looked into this, and the policy has pretty much always been the same, is that to get a student version of SolidWorks, I think that you need to be a degree-seeking student in a engineering or technology field that requires SolidWorks and need to show proof of that. All these CAD programs are they're very strict on their licenses, and to some extent they should be. They're very powerful programs, and I could not probably justify or afford spending the money on them, but the value in them is there that I understand the price for them. So short answer is yes, long answer is yes, but you have to be a degree-seeking student as far as I know. If anybody else has any other suggestions for CAD programs or knows anything else about student versions or other versions of any of these CAD programs, definitely share it on our comments, and I think that a lot of people would be happy to hear of other alternatives.
There you go. We got an answer. You can get a 1-year SolidWorks license if you are, well, not an answer, if you are a veteran. So if you're a veteran, you're set for a year.
Oh, interesting. So there you go. Yeah, that's one I didn't know about, and I'm sure valuable to a lot of guys out there.
Yep. You are all caught up on the questions for now.
Great. Well, it's nice to have questions, and it's nice that people are interested in these. So, so I will go through some of these examples and see if we get any more questions before we wrap up. And so a lot of these things that I've designed, I've either designed for myself or designed for other people that ask me to make stuff for them. Or run into other things. So batten-off masks is one of the obvious ones, and I talked about it a little while before. I think that these 3D printed batten-off masks are head and shoulders above anything else that I've tried that's on the market, and it's because you can put them on the end of your dew shield, and they cut perfectly around your dew shield, so it doesn't matter where you're pointing in the sky. It's easy to print them for your exact focal ratio and focal length, which is also great. So they're, I don't know. I remember using other batten-off masks before that were always just a little finicky and didn't give the sharpest diffraction spikes when focusing. And so these printers really give very nice knife edges. I don't know. This picture may or may not be high enough resolution to show, but the accuracy of these printers is just stunning, and they give very, very sharp diffraction patterns on them. So another example, project that I've done this since I started in astrophotography, is make my own flat panels, and diving deeper into making them better all the time. But one thing that I always was frustrated about with flat panels, well, there are a handful of things. One is, if you go to a star party and you want to take flats, well, then you got to wait till during the day, because you don't want to take flats during the night and bother anybody there with this huge bright light while they're trying to get accustomed to the dark. and if you wait till the day, then you have to worry about light leaks in your camera, or the you know, if you're taking it at home, you have to point it straight up to the zenith, and then you've got, you know, depending on the flat panel that you bought, anywhere between $100 and $450 thing just teetering on the top of your telescope, and just hoping a gust of wind doesn't come by or a giant bee doesn't land on it and knock it off. So using the 3D printer, I was able to make, and I've gotten them thinner and thinner and lighter, but actually sturdier and stronger at the same time, which is kind of, I said, the iterations and experience. You can make things better as you go along. I've gotten to the point where they're very lightweight but very, very sturdy, and same idea where they cup around your dew shield. So, you know, when my scope is done for the night and parked in the morning, I just come out with my flat panel, throw it on there, start my sequence to get my panels, go back in, have my cup of coffee, and I come back out and it's done. Star party, if you want to change the rotation of your camera in the middle of the night, or if you're at your local dark site and other people are there, you can put this on there and you know, take some flats before you change the orientation in your camera for your new target. So just very useful for that kind of stuff. And then adapters, I think a handful of people have purchased this adapter from me here recently. And this is the AFUKUYuopqU Master adapter. And so this is the cool part. I think maybe the coolest part about printers for astrophotography is that there's so many new products that come out all the time. I mean, we just had that session on NEAF a couple of weeks ago, or last week, a couple of weeks ago now, and the market is very competitive, and people have to get stuff out in a hurry to continue being profitable and beat other manufacturers to the market. And one of the things that happens with that is that you run into products that don't seem to have all the perfect solutions. They might be an awesome product. We had the presentation on the PoleMaster too, and it's taken the whole place by storm. You know, I know that they're selling well based on how many of these I've sold, and I know they're selling well because you look at other websites trying to shop for them, and they're sold out half the time, if not more. So they're doing great. But one thing that they had a problem with was that, you know, they've been playing catch up with actually making adapters for all the different mounts. So first thing that I thought, and a handful of other people thought, well, if this whole thing is based on rotation around your RA axis, then why does that have to actually be on your polar axis? And it doesn't. So just coming up with a very rigid and very secure and repeatable way to actually mount the PoleMaster and put it up on a dovetail is just as good. And then you can use it on any mount you want. You can put it on your telescope and change your telescope from one mount to another if you have a observatory and then a mobile setup. It's great. And so walk into the same thing over here. I'll come back to this one, but the same thing over here with that William Optic Star 71, which is what we talked about the previous year as probably being the hottest product. I know that those Star 71s sold like crazy and were sold out for a long time, and I think everyone on the Astro Imaging channels have one at one point, and a lot of our buddies over at Cloudy Nights have them. But one of the things that we noticed with that was that the lens in there is mounted a little bit goofy, in a way that when it gets cold, you get this weird iron cross diffraction pattern. You can see that down on the bottom picture of that star there. And so, you know, as we discussed it, I think before we heard from the manufacturer, we realized that there must be something coming in on the light path to make that iron cross pattern. So, so the obvious answer was, oh, well, let's cut down the light path a little bit. So I tried this out, and it seemed like it worked right off the bat, which was great. And the 3D printer allowed me to print different size masks for different temperatures, because that iron cross is very, very dependent on the temperature. So it was probably the biggest and my only real complaint about that Star 71 was the star pattern, and it really fixed it very quickly for me. So going back, again, this Star 71 was so popular that I think a lot of people had it, and there were a lot of requests for different things to make it better. So another thing that came out of it was an extended dew shield, and the extended dew shield was because the dew shield on that Star 71 was just a little bit shorter than I think a lot of people would be happy with. So I made a handful of these for a few guys around the forums, where instead of having a separate aperture stop-down mask, and an extended dew shield. There's a dew shield that you pop on the end of your Star 71 dew shield with a snap in and out stop down aperture ring, and that way if it was in the middle of the summer you wouldn't have to have your field stop down, and if it was in the middle of the winter, it was freezing out and your stars were starting to get ugly, you could pop that ring in there very quickly. And then I make these flat panels, and my buddy Rich Flynn contacted me and said, hey, I just got this new mount and I'm mounting my telescopes on top of each other and my current flat panel won't actually fit, so to take my flats I have to move the Star 71 way up and it's just very inconvenient. So he said, can you find a way to get me flats so that I don't have to move the scope? So we worked on this project together for a little while, and you can see how I kind of integrated this whole design for him. So just another example of just a way that you can really very quickly solve problems. I think Rich asked for that product, and maybe it was the end of February or something like that, and I think by the beginning of April, or maybe even middle to late March, I think he had it. It didn't really take too long to get that together. So you can make great solutions for either big problems or even for small problems, and just really make it work perfect for you with the 3D printer. And then you can actually do really big projects. And so this is where I want to answer that question before, and I can't remember who you said it was from, Adam, but probably one of the larger projects I undertook was making an EQ platform with a 3D printer, and obviously some aluminum parts on there as well. But EQ platforms are really, really wonderful things. I mean, they're very accurate ways to have big, huge, large telescopes track the sky, like Dobsonian telescopes, and you can put 10, 15, 20, 25, 30-inch telescopes up on top of these very small and very inexpensive to make platforms. And I was really excited about the idea of answering something that was really hard. One of the hardest things about making these platforms is you have to have these compound cuts that are somewhat difficult to even visualize how you make them, let alone actually make. And then you also have to have these curved sectors to have the platform track properly. And ideally, you have all your angles optimized for wherever you live, whatever latitude that you live at. So I thought, well, that's just a perfect project for a 3D printer. And this was something I made a while ago and used for some time quite successfully, observing in my backyard. And you know, it was a very fun project. And so this answers the question. Yeah, there are some times where you can make things that are even load-bearing, depending on the kind of load-bearing that you're getting in 3D printing, and have it be very successful. Typically, you know, you want your 3D printed parts, if you're really going to put much load on them, you want them to be in compression. And as you can see, the biggest load on this one, or the biggest forces on this project, are mostly going to be in compression. As you can see, the circular sector up at the front is being, you know, has all the weight of the telescope pushing down on it, and it's supported from underneath at both the front and the back from underneath, as anybody who's made a platform knows. So this was a very fun project because I was able to make a kind of very unique looking platform that was very lightweight out of aluminum and plastic, and ended up being quite nice. I think that I went through a couple iterations on the aluminum because it was very springy at first before I got it to be more rigid. But so that should hopefully give you some example. I probably wouldn't use a 3D printer for an extension tube or something in shear, or something that has too much bending on it, if he understands what I'm saying. But certainly anything in compression, the 3D printed parts work very well. So I think that's the end of my examples, Adam. And see if there's any other questions or comments out there.
No questions right now, but I'm going to give everyone a few minutes to ask your questions. There's a lot of viewers in the room. Definitely an interesting topic.
Hi, this is Alex. I'm in the room. How long would it take you to show us how to make, say, an 1¼ to 2-inch adapter in that software? Just so we can get a sense of what it looks like to do. Would that be like a 2-minute operation, or would it take up too much time to do that?
I could probably do that real quick.
Let's just make up an adapter and with a set screw coming in from the side or something like that, if we could do that.
Sure. Hopefully this goes well because I'm on the clock. So what I'm going to do is just start with a circle here, center diameter circle, and I'm going to make this the 1 1/4 inch circle here. So I'm going to make this whatever 1 1/4 inches in millimeters. We'll just call it 25 inches. I don't know if it'll let me do that. Yep, I will. Okay. And then I'm going to drag this guy down inside here. And actually I want that on the outside. So usually I'll use something like a 3 millimeter wall thickness. So I'm going to make a dimension here between the two of them, make it 3 millimeter wall thickness. And then I'm going to extrude this whole part here. And I'm going to select the profile I want to extrude, and we'll say that we want that to be about 1 inch. And there you go. So that's extruded 1 inch right there. Just to make this simple, I'm going to do another sketch here on this plane that I just created. And make that there like that. And so we want the outside of this to be 2 inches plus 6 millimeter, or I'm sorry, plus 3 millimeters. I don't know if this program will let me do that. It looks like maybe it did. Yeah, it did. Great. Okay, so now we're going to extrude this part, and we're going to pick this profile right here. We're going to make this 3 millimeters. And let me make sure that's going the right way. It is.
Okay.
And then one more quick sketch here on this plane. We'll make a circle here. And so there you go. We could put just a little hole over here for a set screw very quickly. I'll do that real quick just to...
Would I come back later and thread that with my regular tap and die?
So that would be up to you. There's a handful of ways you could do that. One way would be to use the tap and die. Another way that I like to use with these, and I've actually done this before for adapters, is to put in inserts, threaded inserts into these plastic. And so you can either put a threaded insert into the plastic actually during the print, partway through it, or you can put a threaded insert into it afterwards, and there's press ones that will go into it. So we'll go ahead and make this hole here. Okay, and there you go. So that would be a quick adapter right there for you. And then so you could just press that threaded insert right into there. You could actually print them, print the threads in there if you wanted to for coarse threads. And you can actually tap the plastic itself. The problem is it doesn't like to have stuff threaded in and out of it a lot of times. If you're just screwing something together, it actually does very well for 1 or 2 parts to actually permanently fasten stuff. But if you're using it for multiple threads in and out, I definitely suggest an insert.
Okay, well, I mostly wanted to see just how technical one must be in order to use that software. And it looks like I might be able to do something like that with practice.
Sure, yeah, definitely something like this. You could, like I said, there's lots of tutorials and walkthroughs out there, both from the company itself and on YouTube, just from other users.
Okay, thank you.
You're welcome.
Yeah, that software seems really intuitive. I mean, that's exactly how I would have thought you would have had to do it, and it kind of works that way.
Yeah, that's cool. I'm quite happy with it. Like I said, very happy with it.
And like you said, with the insert, like it's basically you just have to think a little bit smarter about it. Because you could buy inserts from like McMaster-Carr or probably any like off-the-shelf store, and use them as your parts that you need rigid, and then anything that's plastic. I'm even wondering, you could probably do some sort of, like, as if you'd use a nylon gear, you might be able to use this to build a nylon gear if it wasn't something that had to be ridiculously tight tolerances.
Absolutely. I've definitely created gears out of 3D printers and used nylon. A lot of these companies are coming out with all kinds of different materials now that are, quite structural, and the resolution on them is great. Usually these printers will be given two kinds of resolutions. One is the accuracy of it, which typically can be down to 1 or 2 thousandths of an inch, and then the layer height and the layer resolution. I think on the best printers, excuse me, is probably 10 microns or something like that. I think on the good commercial printers is maybe 30 micron, or on the best hobbyist printers is maybe 30 microns, and maybe goes all the way up to 200 microns. And sometimes printers will print at, I don't know. My printer prints at 90 microns, and I think its prints are better than I won't mention names, but many of the professional machines that I've used at work in the past, and many of the other hobbyist printers that you see that claim to be able to print at 30 microns. So, you spend a lot of time, if you're going to buy a printer, certainly reach out to me and spend a lot of time reading reviews before selecting one.
Bob's asking if you have any recommended websites for do-it-yourself 3D printers.
Sure. There's a lot of them out there. I'll just keep going back to 3D Hubs. It's great because it not only is a place you can buy and or sell your parts, you can also find reviews of all kinds of printers. And the reason that I say 3D Hubs is that the reason it's my favorite is it's basically run. There is a company, 3D Hubs, that I'm impressed with, but almost all of its reviews come from users because the whole website is built on users and the public and their use. And so if you go to 3D Hubs 3D printer reviews, and the do-it-yourself ones or the kit ones, then you'll read reviews of the best kits. And there's a lot out there, and they're changing rapidly. I took a few years between last time I was really interested in 3D printers and the last 4 months now or whatever it's been, and it's cool to see how much things have changed and what's available out there now. But yeah, that would be the best place to start is 3D Hubs and the reviews on do-it-yourself kits, and then that'll give you some good examples of ones to start looking at.
Josh, how much is the printing media for this?
Again, completely depends. The printer that I use sells 1 kilogram spools for between $30 and $60 depending on the material you use. Professional printers I used at work have 1 pound spools for $300 a roll. If you go away from FDM to SLS or SLA, you might be spending far more than that per material, but that's pretty much how they're sold. I think that the cheapest ones you can buy are probably $15 or $20 for a kilogram spool, but then you start running into quality issues sometimes. I prefer to spend a little more money and know that the material is going to be very good. They even have products out there where you can make your own material. Again, you have to trust your manufacturing process to make sure that you make the material right, but you can at that point buy the raw materials to extrude these filaments for even cheaper. So I mean, you could go all the way down to probably $5 for a roll if you had a high quality extruder to make your own filament, up to hundreds of dollars. I think typically hobbyist ones are probably between 30 and 60 is about right, maybe 20.
And one of the things we haven't, I haven't heard asked or answered, there must be websites out there with databases of pre-existing, maybe not for astrophotography in general, but for 3D printed parts. So basically, someone's probably already designed something that you need, and you can, I'm assuming, go to the database.
Yeah, absolutely. And so some of the files that are out there are just STLs, which are ready to print. Some of them are CAD files, which are ready to open and modify, and they're all over the place. I will say in astronomy circles, there's not a ton. There's a handful of Batnoff masks out there. There is actually a couple of interesting things. One thing I didn't mention is that there are people 3D printing telescopes now. I haven't used one. I haven't seen the results from them, so I can't personally comment on them. But it sounds very, very interesting. Again, to me, some of it is, I like to say 3D print what makes sense and not just 3D print for the heck of it, but aluminum tubes are pretty cheap, and I don't necessarily think that the best thing to do is just make a whole a whole product 3D printed when you have other materials that are cheap and make sense. But I will list these in the comments section, but there's a lot of sites that have files. Thingiverse is probably considered one of the most popular, and like I said, I'll put that in the comments, but Thingiverse has a wide array of parts of everything you can possibly imagine. GrabCAD is probably more focused on engineering type things and design type things. I don't know. I won't list too many of them, but those are the two main ones that I think everybody knows off the bat. Who you would ask, but I will certainly list some of those in the comments section, as well as some others.
Awesome. Tell me about this S-Big helical focuser.
Is that you asking?
Yeah, I'm just curious. Just a two. Is it simple or is it?
It's a two-piece part that has one piece. I guess you're familiar with it because you have it. The bottom piece has an L-shaped or two L-shaped grooves, so that the two thumb screws that are on the S-Big OAG, it basically goes down onto the focuser and then rotates and locks into position. You tighten those two thumb screws, and then there is a helical plastic part on top that you rotate up and down to catch your focus. But then there's also a couple of thumb screws that actually tighten the camera into place, so your camera actually stays in its orientation as it's focusing up and down. And then once it gets focused, then you lock the focusing part into place, and then you can rotate your camera into whatever orientation you want, and you can lock the camera into place. I probably have some pictures I could bring up for you of that too somewhere. But yeah, it's two plastic pieces, and you use the thumb screws that come with the S-Big OAG, and then I put a couple. Actually, that's one of the products that I used threaded inserts on. I used a couple threaded inserts and nylon thumb screws because that way you wouldn't mar your camera.
Yeah, it's interesting because you said sometimes you have to weigh the costs, and you might find that making a metal part is better, but there are times that I've had an issue or something like that, and I said, if I had a 3D printer, maybe not in this astrophotography so much, but I had an issue where I said, if I could just make a part that would do this, I could solve this problem. And even I remember a story about NASA 3D printing a wrench in space.
Yeah.
They needed a wrench, and they didn't have it, and they just 3D printed it, and it solved the problem for them. And in that case, it probably saved them a ton of money. What? Cost of launch, a little bit more than my budget, but some of us would like to throw money at something, or even just throw a couple hours of thinking at a project and solve it that night instead of waiting for UPS to show up a couple days later.
Yeah, absolutely. I mean, you can solve so many problems. It's funny. I mean, I think that they're amazing machines and they're great. I don't think that they're anywhere close to replacing modern-day manufacturing. They're still too slow. They're still not as good as molded parts. But they're amazing for development, and in the right circumstance, they're very useful end products. So, I mean, it really depends on what you're using them for. But like you said, I don't know. I think a lot of people get them and play around, and they use them mostly to make other printers and trinkets, and then some other people really get into them and they make robotics stuff, and they make and they make whatever. They make all kinds of useful stuff. So it can be all over the place. But I completely agree. It's great to be sitting there thinking about what you want, or that you need something and be able to have it later that night. Especially when it doesn't exist. I don't know, today with Amazon and everything, I get so antsy that usually it's at my house the next day if I really want it. But if there's something that doesn't exist or in the form I want it, you get that itch to make it pretty quickly.
Yeah, I can think of a few things. In some cases, a pipe wrench for like a weird thing. I've had to do it myself. I have a reverse osmosis system, and I lost the wrench, and I needed a weird shaped wrench, and they want to charge a ridiculous amount of money for that wrench. And I kind of needed it immediately, and well, I lost the wrench, so I couldn't do it. But so I ended up paying the $40 they wanted for it, but for a little plastic wrench. And 3D printer might have made it really handy. But,
so, oh, sorry, Adam, I didn't mean to speak.
Go right ahead. Go right ahead.
So I obviously missed the very first part of the presentation, but did you happen to cover the different kinds of materials that you guys, or Josh, that you use for your printing? Do you use ABS, PLA?
I usually use ABS, although I've started using some other materials. Well, and it's also very project dependent on whether it's going to be outside, and if you get away from astrophotography, whether or not kids will be touching it or it'll be touching food. But I've gotten more into this company that I use has something that's essentially like a strong glass-filled nylon. They have something that is a stronger version of ABS. There's a PC ABS. The strength of some of the materials that are starting to come out is really impressive. But yeah, typically I will match whatever material is needed for the load situation. I do not use PLA very much. I think it's good for prototyping, but I do not think it's very good for making final products that actually need to withstand much load.
What about the ceramics? What would they use the ceramics for?
Electronic stuff. That's what I've seen mostly at this point. I'm not sure. The ceramics was still a very new thing. I watched a seminar on it at the 3D Expo in Pittsburgh a couple of years ago, and I think it was very early in its development, but it was used mostly in electronics and insulation stuff.
Okay, yeah, I was going to say for high temp stuff, because maybe not high temp because they mostly melt the material to lay it down, right?
Well, this is different. This one is actually, instead of melting, is actually being laser cured, I believe, for the ceramics. So the FDM is all stuff's being melted. There's also, technologies where they have powder that actually, where lasers run over the powder and actually cure it. And then there's other ones where lasers will actually, I can't remember the exact word for it, like the metal is actually sintering it.
Okay. Yeah, it's interesting. With a combination of, you're getting complex here, but with a combination of 3D printing something, then making a mold of it at home, then using some sort of, I know you can do the UV, what is it? You use like a bonding agent in UV, you can make a really, really solid part.
Absolutely. I do that a lot. 3D print parts, make 3D print molds, or I will 3D print a part, then make a mold, and then mold the parts. Yeah, if you need something. So the one thing about 3D printers is that obviously your strength is going to be a lot different, whether it's whether it's along the print lines or not along the print lines. If you want something to have its strength in all orientations be pretty much the same, then you want to make a mold, and it's actually pretty cool and pretty straightforward. I took a mold making class where we made these little plastic helmets. And that was from 2 3D printed parts, and then so I moved on from that and learned how to start making my own stuff. And certainly in situations where you need high strength and really solid parts or watertight parts, then you might make a molded part.
Yeah, that's really cool because one of my buddies, he does a lot of drone racing, so he makes his own skeleton frames, and he uses a nylon printer. So they have carbon fiber printers. I'm not sure if you guys talked about those, but I had no idea they existed up until about a week ago. And so they can print out, one head will print nylon, and the secondary head will print carbon fiber to reinforce the nylon itself, so you can have a composite frame. The price is insane. It's stupid expensive.
The carbon fiber is really in its infancy still, and is kind of really dependent on the model. But drones is a perfect example. That's something that, you know, it's not super expensive to get a frame, but it's expensive. And usually a frame is sold as a whole frame and not the part that you need. And I certainly know that from all the time I've spent flying drones. And you break drones a lot, so it's great to have a printer that can print stuff strong enough that as soon as you break a part, you know, maybe you have a full backup set waiting, and then you just print that one replacement to put in your backup set. But that's certainly a situation where it's very helpful.
Very cool. And there are a lot of people in the room. Popular topic. We might have to revisit this as I'm sure it's going to be a completely different world in 6 months because it's developing so quickly. I remember just a few years ago you had to build your own 3D printer.
Yeah. When I first started, there was one company that unfortunately just closed its doors a couple months ago, but they were the first company probably in the world to offer like a relatively affordable 3D printer that you could buy off the shelf. Now there's quite a few of them. They're still, you know, the quality is questionable down under $1,000, and the repeatability is questionable. You start spending a little more money, it gets better and better. And in all honesty, there's very few that are really truly plug and play at this point. The one that I just bought, I'm very happy with, and I think as close to plug and play as you're going to get. But a lot of them, you're still going to tinker a little bit. You're going to solve problems that come up, but the quality is going up and the prices are coming down for sure. So the good thing is that means that there's more accessibility to all the smart people out there who want to do things with them.
Did you happen to talk about weight bearing? What's the heaviest that you've been able to print parts? I'm curious just to see what your experience is versus what my experience has been.
Yeah, so we talked about it some and talked about the situations. I don't know if you saw the equatorial platform that I shared.
No, I missed it. You don't have to go back to it. I was just curious if you had. Then I'll just go back and watch the video myself.
It's yeah. I mean, the best way to use these parts is in compression. If you want to put a lot of force on them, it's always in compression for printed parts. You don't want them to be in shear as much, and if they're going to be in shear, you want to make sure that your printed lines you're not shearing across. You want to shear in a way that you're not trying to shear right along the lines. Otherwise, they're going to be easier to shear off. You don't want to torque along the lines. But yeah, I've made an EQ platform that had a 10-inch Dobsonian writing on it, with mostly printed parts. I've made some eyepiece extensions, like I mentioned, that were not quite. I had to make them thicker to make them work as well as I wanted them to. But I don't know. It gets down to the engineering a little bit to really know what can flex and not. I've made dovetails for smaller scopes that worked well. I probably wouldn't do it for anything real heavy.
Josh, can you take a part that you printed and reinforce it once it's done in sections of that printed material which is not close tolerance? It doesn't have to be fitted.
Absolutely. I mean, well, there's two ways to do it. One is just to add the reinforcement into the printed part and add more material, which is easy. The other way, if it really needs to be strong, is there's two ways. One is just lay some steel on it, or screw a steel bar or aluminum bar to it. The best way to do is integrate it in your design. If you know it needs to be stronger for whatever purpose you're using, integrate a pocket or something like a notch for you to actually run a steel bar or a steel ring or whatever, or an aluminum bar or aluminum ring in it. And yeah, I've done that quite frequently. Is just planned on and integrated, having reinforcements from stronger materials.
So you can stop halfway through a process, lay in a little rebar, and then continue on.
Yep. Same thing with those threaded inserts. Yeah, you can absolutely. Sometimes I put nuts into parts, like if I wanted a lock nut to go into something and I didn't want it to be visible on the outer surface, or sometimes I wanted something to be really strong in one axis, so I would put like a a little tiny T-beam in there or something like that, and then continue the print. But yeah, absolutely, you can go in the software and tell it, when you get to a little more advanced slicing settings, you can tell it to pause at a certain point and insert whatever you want into there. Magnets is another thing.
Do that?
What's that?
You have to design a void area where you can put in those parts.
Yeah. I mean, well, I don't want to say have to, but yeah, I mean, you would typically design a void for it, yes.
So it actually prints around that. Like if you do put that void in there, it actually prints around it and potentially bonds it to it, or.
It probably wouldn't bond it to it, but like I don't know, like if you wanted to put magnets in something, like along the edge of something that you wanted to stick to a wall or to one of your astronomy parts, you would have it print a few layers and then have it print another 50 layers that go up 10 millimeters with little pockets for those magnets. Put the magnets in there and then have it print over top of those magnets so that it basically perfectly captures those magnets, something like that. Or you could do the same thing with like a T-bar or something like that. You obviously want to keep in mind the geometry of your printer and your print head and make sure that you're not putting something in there that it would run into. So definitely gets into a little more advanced operations, especially if you're using anything that's not just a flat plane that you're inserting into your part.
Do you have to, does it create a weak point if you stop and start?
It depends on your printer and the ambient environment. If you have a printer that is open to the air and you stop the print, then yeah, it can certainly create a weak point because it can cool off on the top and the next layer won't bond as well. If you have a printer that has sidewalls at least and maybe a top wall at best, then it'll control that temperature on the inside and it'll keep the plastic and the material at a high enough temperature that your next layer will definitely adhere very well. So, like anything else, it depends. Depends on the printer. People will modify their own printers to make those improvements as well. I think at one point I even put a little space heater with ductwork into my printer so that I could pump heat into the ambient environment, so I didn't run into those kind of issues.
So have you made yourself a Josh Smith figurine yet?
I have. Well, I will pull this up before we go off the air because my mom will love it. This was a present that I made for her maybe a year or two ago. But it's worth me pulling it up because it also incorporates those 3D scanners that I built with the Kinect system. And I think I not only creeped out my family, I think she put it up at work and I creeped out like half of the Pittsburgh area with this. But I'll pull it up as we're chatting here in just a second.
I always figured that giving something like that to someone was the perfect birthday gift, giving them a little figurine of themselves.
Oh, you know what? I'm going to share my screen because I forgot there was a couple other things that I wanted to show that were kind of more original and creative as well. Let me make sure I'm actually sharing my screen. Okay, can you see?
Yep.
Okay, so here's the figurine of my. I made a rotating candle base with all the children and grandchildren for my mom, and put it into this rotating candle base. So I did what do you call it? I used the Kinects to actually scan everybody in the family and make this rotating candle base with that. And let me go back and show one of the other things that I really enjoyed doing, and I think maybe I shared this before on this channel, was making these 3D printed pictures of astrophotography pictures. And there's this program, I wish I can't give credit to it now because I can't remember the name of it. I think it was 2D to 3D Mesh or something that I bought, and it was a great program, and it basically took pictures and turned them into 3D topography maps. So these pictures I took of Jupiter and M51 and Saturn made into a topography map. And at the time I had a 2 or 3 head extruder that I modified to print different colors. I think that you can actually buy them made that way now, but at the time you couldn't. And so I had 3 different or 4 different kinds of materials that I was switching in and out of there, and I actually made these window wall panels out of my pictures that I took in the night sky, and you can see they're kind of translucent, very cool. And I even made a light box of Saturn, this was a 3D printed light box with 3 different materials and a light behind it that I made for my dad at one point. So you can also get very creative with the 3D printers too.
Awesome. All right. Well, that was a great episode. I still see a few viewers in the room. I'm going to give you a few seconds to ask more questions, but I did want to mention next week I'm going to be on vacation, but the show must go on. So Alex is in charge. Maybe I will catch you from the balcony of my hotel, but next week's show is the Sensor Sense Show. So we're going to go, Alex will cover a bunch of different sensors, your options, and which one you may want depending on your specific needs.
Yeah, let me break in here, Adam. Yeah, by the way, as you probably know from if you're a regular on this show, I'm not generally a real geek as far as following, all the pixel size, which is the latest chip, which is that, this, that, the other thing. This is going to be a basic presentation as to what kinds of things to look for. The other guys on the show generally are pretty good at jumping in and saying, oh, no, that's got a .457 pitch, and that one's got a 16 by 32, or whatever. I'm just going to tell you which questions to ask and stuff like that. And as we're developing here, it looks like it's a little bigger than anybody would be willing to sit through in one session. So we're probably going to break it into 2 sessions, and next week will be more along the theory of what a sensor works, how a sensor works, and some of the specifications you get for sensors, and some generic statements about different types of pictures. You get better sensors with certain sensors work better with certain types of pictures. We'll get a little bit of that, some stuff, and then we'll come back probably May 15th, but that's not firm yet. And we'll actually ask some of the questions now about like transitioning from a DSLR to a CCD, whether to go ahead and modify, what kind of modifications to make in a DSLR, what advantages you get. We're going to talk about covering your choosing a tube to go with a particular sensor and stuff like that. So that's our plan right now. But I got to tell you guys, look, if I can do this, you guys can do this. I know there's a lot of very competent imagers out there that can sit here and talk about something that you're doing or something that, you see the arguments on cloudy nights. You see them going on and on. You've got one side or another or both sides you'd like to present. You know what the common topics are that we need. You can sit and you can actually tell some people, and really people get a lot out of it. So I really want you to contact Adam and volunteer to do 30, 40 minutes sitting at your computer at home some night, just telling people what you know about something. Make up a little PowerPoint if you like to, or just process a picture on your screen and let other people watch. That's all we're really doing, guys, and you can help do that. So everybody that's out there is listening and haven't thought about doing it, just get a hold of Adam and tell him that you'd like to talk about a particular topic. He'll get you in scheduled. He'll do it. So I'll leave it at that.
Thanks, Alex. I just got the comment in the comments thing about it would be great if we would turn on comments, and I try and mention this a bunch of times during the episode. Q&A is what is referred to as comments. So when we say Q&A, that's our comment thread. I think if you hover over the top right of your screen when you're watching this, if you're watching it in the Google Hangout, then you can ask your questions live. If you're watching us on YouTube, it's a little bit difficult for us to get to that comment area. I'll look into that and I'll figure it out. We had plans to do it a slightly different way, but it's not quite working out for us. So if you guys want to comment live, you really have to sign up for Google+. And I know Google+ is hard to navigate, but you'll get access to that functionality, that Q&A functionality where you can ask live questions. If you're watching us on YouTube, we don't see the comments, even if comments are enabled. It's kind of hidden in a different area. But I will look into that. Maybe we'll be able to monitor it as well. That's what I have to say to that. I'll look into that, and but really get into Google Plus, and that's the best way to watch this if you're watching it live. Remember, if you're watching it on YouTube, there's even more of a delay than if you're watching us on Google Plus. So sometimes you might be asking your questions and we're already done. But that's for the one person who mentioned that. And even I just got that comment, and it's half an hour later, so there you go. Yeah, thanks, Josh. Great presentation. I still see a bunch of viewers in the room, so but I haven't seen any recent questions pop up. So if nobody else has anything, I'm going to say one last call for comments, but pretty much within the room. Otherwise, we're going to end up seeing you next week. But good night, everyone. Thank you, Josh, one more time.
Thank you.